Okay, this is just to kind of help you with the energy problems that we're working on. So we got a cup of liquid water. So I know this is a liquid. I'm going to use something from here. At 150 grams, there's my mass. It's heated from 25 to 50, or to 75, so that's a 50-degree temperature change. How much heat does it absorb? Well, I know that it's at 25 to 50, 75 to 75. That's somewhere over here. So I'm going to say for every, well, that's this right here, 4 joules of energy, 1 gram of water changes 1 degree Celsius. And we could say for every blank joules of energy, we're changing 150 grams of water, 50 degrees Celsius. So this is times 50 times 150. Both of those with energy. More mass means more energy. More change in temperature, we need more energy. So both of those are direct. So we're going to say 4 times 150, which would be 600, times 50, 30,000. Okay, I'm going to skip ahead to number 7. Number 7 says substance A is a liquid at room temperature, which we know is about 20 degrees Celsius. It has a melting point of negative 20, so it's the point at which it melts, and a boiling point of 85 degrees Celsius. And here's a bunch of other stuff we know. They want us to construct a cooling curve. So we're going to start as a gas. We're going to go down to a liquid. We're going to make it a solid. And it should be somewhere around there. So to get, once it's the point at which it condenses, they tell us is 85 degrees Celsius. So water we kind of assume is 100, but this substance is 85. And then it has a melting point of negative 20. We know that water has a melting point of 0. So that's at negative 20. Okay? So now it says calculate the amount of energy required to heat 25 of this liquid from a temperature of negative 5. So we're on this graph. We're somewhere up here at negative 5. And we're going to take it up to 95. So we're going to get 1, 2, 3 trends to contend with here. So I don't need anything about solid at all because that part would be over here. So I don't need that. I also don't need this one because this is the melting point. I'm not using that trend. And so I'm really only looking at those 3 trends. So I'm going to say for every 2.5 joules, 1 gram of, this shouldn't say liquid water, this should say liquid A, of A changes 1 degree Celsius. And then we need this next one, 500, 1 gram of A vaporizes. So that's the second trend right here. And then the last trend right here is going to be for every 0.5 joules, 1 gram of A gas changes 1 degree Celsius. Okay? And I'll do number 9 over here. What am I? Oh, you know what? Let's skip ahead. Let's do number temperature change. Let's do this one here. A cup of liquid water, 10 grams, absorbs 400 joules of energy. So it's liquid water. We're going to assume that it falls in here. It's not going to change phases. So every 4 joules, 1 gram of water changes 1 degree Celsius. We got 400 joules. And we got 10 grams. So this is times 10. And this is times 100. So we got to figure out, okay, well, I know that mass and change in temperature are inversely related when energy is constant. And energy is not constant here, but for our purposes here, we're going to need to do that. So this is divided by 10 and times 100. So our change is 10 degrees Celsius. Now, what's happening in this problem? Well, it's absorbing energy, so the temperature is going up. If I were to draw a particle picture, I would just say, okay, this is still a liquid. Just got more swooshies. Okay, I hope that helps. I'll be around second period tomorrow, and if you got any other questions, you can email me. Have a good night. I'm really